Good morning, everyone. I'm Mohammad Ikbal Hossain, and it is a pleasure to present today with Dr. Tanja Steigner. And our topic is the reassessment of Bitcoin mining in terms of energy utilization and its evolving role in promoting renewable energy technologies. And we are grateful to the Blockchain and Internet of Things 2025 committee for this platform. Now, Bitcoin mining is often criticized for its immense energy consumption. It relies on a proof of work mechanism that demands miners solve cryptographic puzzles to validate transactions. And you know that this secure but intensive process is fundamental to the Bitcoin network's decentralized in nature. Now, if we think about the environmental concerns and the narrative shift, we have seen that this high energy requirement has led to widespread environmental concerns, especially the carbon footprint, fossil fuel dependencies, and e-waste. But we believe it's time to look at this issue through a different lens, like mining as a potential asset for sustainability and proper integration with surplus renewable energy is inevitable. And on that ground, our goal is to examine how Bitcoin mining can utilize excess energy, such as curtailed wind or solar power, to improve grid efficiency and promote renewable investments. We'll walk through empirical findings, visuals, and case examples that utilizes this evolving role. Now, we would like to say that what is the dominant criticism? I mean, what we have found out in the related literatures. The mainstream literature emphasizes mining's massive energy use, open light to it to the demand of small nations. Like if you see that fossil fuel reliance and frequent hardware replacement worsen its sustainability profile. These criticisms are valid, but not the whole picture. Because recent studies highlight how Bitcoin mining as a flexible energy consumer can use otherwise wasted renewable power. It can stabilize grids and is increasingly situated near green energy sites and spurring infrastructure investment. And if you say in this figure that energy consumption over time, and this graph indicates that the rising trajectory of Bitcoin's energy use, while steep, this growth invites the question, can this demand be steered toward clean, surplus energy rather than fossil fuel dependency? Then a more nuanced picture emerges, where Bitcoin mining has risk but also potential to align with climate goals, especially when renewable sources and proper regulation are prioritized. And if we would like to say about the data analysis and the framework of our study, we draw from peer-reviewed research, CBSCI, IEA reports, and case studies in Iceland, Texas, and Sichuan. And our analysis uses descriptive and trained metrics to assess energy use, grid effects, and renewable adoption. Where the key findings we have found out that is mining absorbs surplus renewable energy, enhances grid stability and efficiency, drives green energy infrastructure, but there are some challenges are remaining, which are scalability, regulatory uncertainty, innovation in consensus mechanisms. Now, if we'd like to say that the trend of Bitcoin mining over the years from 2009 to 2024, we have seen that the exponential growth in mining activity. The industry scale underscores why understanding its environmental role is more urgent than ever. Then if you go through the surplus energy, this histogram, you can see that the like of weak wind or midday solar is often curtailed. Mining can act as a local responsive load, making this energy productive instead of wasted. Now, based on some case studies from the Iceland, Texas, and Sichuan, Alberta, and Norway, are the examples of where abundant renewable energy supports mining. Actually, these locations demonstrate successful mining renewable integration. Yes. Now, if you see the table 2, how is the energy mix trends? The share of renewable energy in mining rose from 35% in 2019 to over 50% in 2023. So this scenario is really remarkable. And this reflects increasing alignment with sustainability goals driven by policy, innovation, and cost advantages. And at the same time, if you go through the grid stabilization, right, we can see that mining operations can flexibly absorb power surpluses and falls during shortages. Actually, this dynamic helps stabilize renewable heavy grids, reducing the need for curtailment. And if we go through the energy market balance, that time we can see from the literature review that Bitcoin mining reduces curtailment by up to 15%, cuts negative pricing incidents, and drives around $1 billion annually in green energy investments. It also uses energy from isolated standard sources and enhancing overall efficiency over the time. And if we'd like to say something about the green investment driver in figure 5, you can see that the mining has helped deploy solar and wind farms, which create around 60,000 jobs and at the same time cut emissions around 30%. So co-location and long-term energy contracts support scalable green energy systems over the time. And if we'd like to say something about how we can address this energy waste, and if we go through table 4, and we can say that around 40% of mining's energy comes from surplus sources. By turning waste into productivity, mining provides value to otherwise unused energy. And at the same time, we'd like to highlight once again about the environmental concerns, which is over half of mining now uses renewable energy. Operations powered by renewables emit around 40% less carbon, and many miners are relocating to greener regions. And if you go through this slide, you can see that the scenario of e-waste, where e-waste is real, but increasingly addressable. How? Because, hardware efficiency has improved by 20%. Average lifespan is now 3 to 5 years than before. And you see there is 25% of components are recycled nowadays. So what do we think about in our policy implications? For the policy implications, we would like to recommend something for them, like that is tax credits for green powered mining, energy source transparency mandates, of course, And of course, they need hardware recycling standards and grid-friendly operations frameworks. And at the same time, for the practical applications, we are allowing them to mining can be deployed in surplus zones to absorb intermittent energy. Partnerships with renewable farms and investment in storage solutions will be key to further progress. So if we would like to say something about the key discussions, we would like to say that mining act as a flexible load where uses over 50% renewable energy. And the main thing is the challenges traditional energy waste narratives. But the limitations exist, especially regarding data unavailability and long-term global effects. So now, based on our study, we are calling some future research that is based on maybe deeper studies on mining scalability in the global south, higher analysis of economic ripple effects, and future studies can be conducted on role of carbon capture and battery system in mining's evolution. So finally, we can say that Bitcoin mining is evolving from a high emission risks to sustainability partner with throughout regulations, innovation, and collaboration. It can become an enabler of clean energy goals. Thank you for your attention, and